Welcome to session 2 of Csit 103, Introduction to Computing. This session will take us through the computer hardware and the computer software. These two are integrated and consist and make up what we term as a computer. We will look at overview objectives of the session, and the session outline will also discuss will be computer hardware, which we will look at CPU, primary storage, secondary storage, input devices, output devices. Then we will look at the software, which are mostly grouped into 2 or 3. First, system software, and second, application software, special purpose softwares. The reading list, you can find it on your LMS on the UG website, which is the Sakai. Computer hardware devices. Components. We have basic computer functions, which include accepting input. And when we say accepting input, it's the process of taking instructions and data into the computer system. Then another function called store data. The storing of data consists of processes of saving the data and instructions so that they are readily available for processing whenever required. You can work on it anytime and any moment you need it. Processed data also takes care of performing logical and arithmetic operations on data in order to convert them into useful information. Then output information. When you are to output, is the process of producing useful information or results for the user. Then the workflow component directs the manner and sequence in which the above operations are performed, and this is what is the control unit of the computer system takes care of. So we have the diagram here depicting the process we have discussed. We have the CPU, which consists of control unit and arithmetic logic unit. The CPU plus the computer memory unit is actually what we term the system unit. Then we have the output unit, which brings out useful information and show it to you or for further usage. Then we have the input device or the input unit, which actually feed data and instruction into the computer system or the system unit. We have central processing unit, which I mentioned consists of 2 main devices, the ALU and the control unit. The central processing unit is the brain of any computer system. It performs arithmetic and logical operations on data. It coordinates all computer operations. Programs, software provide the CPU a set of instructions to follow in order to perform a specific task. But they are being processed. This instruction is always processed by the central processing unit. Then in the central processing unit, we have what we call a bus. The bus is just a pathway between any 2 components where the fetch operations, the decoding operations, and all take care of. This bus also have its basic units and distinctions. The CPU contains 3 main components: the arithmetic and logic unit, the control unit, and mostly registers, internal memory. So as you see in the diagram, we have the control unit and the arithmetic unit on the same level with the registers below, because data that the arithmetic unit needs to work on is taken from the register, which is a kind of storage, internal storage for the CPU area. So the control unit works on the instructions as they are picked and direct the paths within the processing unit. The arithmetic logic unit. This ALU consists of 2 smaller units, namely the arithmetic section, which works on all arithmetic operations such as addition, subtractions, multiplication, divisions, logical, and so on. Then we have the logic section. Performs logic operations such as comparison, matching, merging of data, and selection of data. Typically or, and not operations. ALU uses registers in its operations. Data to be manipulated are copied from main memory and placed in registers. That is why we have internal storage in the CPU section or components. Results of arithmetic operation can be transferred from the registers to the main memory. ALU also uses adders. The adders perform arithmetic operations on the binary digits. In the ALU arithmetic operations, steps in adding, let's example, typical two numbers, we put adders A and B in separate memory locations through the keyboard, and then step 2, we fetch these adders from the memory locations into data registers in the CPU location. Then step 3, ALU uses the accumulator and add the two numbers. Then step 4, the ALU stores the resulting value in memory buffer registers. Then step 5, finally, control unit stores the results into a user desired memory location. That is, take it from the register, buffer register onto the main memory, which is the RAM. This is the diagram. So we have A and B as input into the system, first stored in the main memory, and then as they store in the main memory, they are being taken by the data into the data registers here through the control unit, through the bus system, and they are kept in the registers here till they are ready for processing, where they will be fetched into the accumulator, and then additional unit in the ALU system will take it up. And so finally an output goes through here into the buffer storage here, and then it will then fetch through the bus system into stored in the memory here as an answer, which will finally be displayed through your output unit. The control unit. It controls the computer system. Functions performed by CU include directing and coordinating computer operations, activating the appropriate circuits necessary for input and output devices, interpreting instructions, fetch from main memory of the computer, sending control signals to the devices involved in the execution of the instructions. The control unit contains a temporary storage location called an instruction register. So as we have seen, we have mentioned 3 registers: data registers, buffer registers, and instruction register. The control unit, till all instructions are executed, control unit follows these steps. Retrieves instruction from primary storage into the appropriate register, send instruction to the instruction decoder for analysis, then decoder sends signals to other components of the computer that causing instruction to be performed. CPU registers. They are small temporary storage locations within the CPU, termed as the internal storage system, manipulated directly by the control unit, designed for specific function, size in bits or bytes, not megabytes like memory. They are smaller units than memory system. Then can hold data and an address or an instruction. As we seen earlier on, we have data registers, we have buffer registers, and then we have instruction registers. So use of registers: hold data needed quickly or frequently, stores information about status of CPU and currently executing program, holds the address of next program instruction, signals from external devices. General purpose registers hold intermediate results or data values, example loop counters, typically several dozen in current CPUs. Basic functions performed by the ALU are the subtraction, addition, and division, and OR operations. We have shift left and shift right on tools complement binary numbers. The inputs to be calculated are stored in input registers, and the inputs output registers as accumulated. Then shift left and shift right functions operate on the value in the accumulator. So this is what takes place. CPU special purpose registers. They are program counter register, also called instruction pointer. Then we have instruction register, which stores instruction fetched from memory. Then we have memory address register, stores the memory address from which data will be fetched to the CPU, or the address to which data will be sent and stored. As you study computing, you see more of these registers and their operation and functionalities. Special purpose registers. Memory data register contains the data to be stored in the computer storage or the data after a fetch from the computer storage. There is status registers. Status of CPU and currently executing program. Flags, 1-bit Boolean variable to track conditions like arithmetic carry and overflow. Power failure, internal computer error. Primary storage. Stores data and instructions needed for processing. Memory is divided into smaller units called cells. Each cell or location has a unique address, which varies from 0 to memory size -1. Memory can be classified into primary main storage, cache memory, secondary memory. Cache memory is used to hold most frequent data and programs. During processing, we have the cache standby so that repetitive instructions, the instructions that you occur several times, are stored in this, so that you don't always have to go and fetch them from the memory into the registers. So it makes the activity fastest. It creates a smooth and speedy atmosphere for the operations. It acts as a buffer between the CPU and main memory. The advantages are faster than main memory. It stores the program that can be executed within a short period of time. It consumes less access time as compared to main memory. Why? Because the cache is closer to the CPU in terms of arrangement of the internal system than the main memory. So the cache memory is, as displayed here, is limited storage capacity but quite expensive, and that is why it's not affordable in terms of higher capacities. Primary main storage holds the data and instructions on which computer is currently working on. Main memory consists of RAM and ROM. Characteristics of main memory: semiconductor memories, they are volatile in the sense that the moment you put your computer off, all data stored in the main memory is vanished. Data is lost when power is off. It is the working memory of the computer. It is faster than secondary memories. A computer cannot run without a main memory. Random access memory. Internal memory of the CPU for storing data, program, and program results. It is a read-write memory. It loses its data when computer is turned off. Hence, a backup uninterruptible power supply is often used with computers. RAM is small in physical size and the amount of data it can hold as compared to secondary storage. Random access memory types. We have static RAM and dynamic RAM. The static RAM is normally named as or termed as SRAM. Static RAM, which is SRAM, is static, indicates the volatile nature of the RAM. SRAM chips use a matrix of 6 transistors and no capacitors. SRAM need not be refreshed on regular basis. It is more durable than DRAMs. Dynamic RAM, DRAM, made up of memory cells which are composed of 1 capacitor and 1 transistor. DRAM must be continually refreshed to maintain data, mostly used for system memory. It is cheap and smaller compared to SRAM. So we see the differences between the SRAM and DRAM. SRAM has long life, there's no need to refresh, it's faster, used as cache memory, large in size, expensive, high power consumption. DRAM is short data lifetime, need to be refreshed continuously, slower as compared to SRAM, used as RAM, lesser in size, less expensive, and lower power consumption. Read-only memory is also another part of the memory that can only be read but not written onto. It is non-volatile. That is, information in this capacity or in this ROM is fixed. Information on it is stored permanently on it during manufacturing. So as a user, you don't have any control and dealings as you operate the computer with ROM. ROM is stored data for the computer resources that you are using. Read-only memory types. MROM, mask ROM, hard-wired device that contains a pre-programmed set of data. PROM is programmable ROM, can be modified only once by a user but not erasable. EEPROM, erasable and programmable ROM. This can be erased by exposing it to ultraviolet light for a duration of up to few minutes. EEPROM, electrically erasable and programmable ROM. This is programmed and erased electrically. So these are the different types of ROM we have in the market. Read-only memory advantages. They are non-volatile. Information on it cannot be accidentally changed. Cheaper than RAMs, more reliable than RAMs. Its contents are always known and can be verified. It is static and do not require refreshing. This is why ROM is being set aside for the computer usage in terms of storing of its resources. ROM versus RAM. ROM is non-volatile, RAM is volatile. ROM is cheaper than RAM. RAM is very expensive. The content of ROM are always known and can be verified. The contents on the RAM are not known. ROM cannot be updated or corrected. RAM can be updated and corrected. ROM serves as permanent data storage. RAM can serve as temporary data storage. Secondary, or what we call backup memory. These secondary devices are used for storing data and information permanently until deleted or destroyed. Data on it are accessed via inputs, outputs, routines. Note, CPU has no direct access to it. Characteristics of secondary memory. They are magnetic and optical memories. It is non-volatile, slower than primary memories. Secondary storage are all used as alternative memory, where data after processing and outputted can be stored for further or later usage. Primary storage versus secondary storage. Primary storage stroke memory is also called internal or main storage, high speed. Secondary storage or memory is also called external or auxiliary storage, low speed. Primary storage is very expensive. Secondary storage is not expensive as primary storage. It holds data or programs. Primary storage holds data or programs temporarily. Secondary storage holds data or programs permanently. Primary storage holds programs and data in current use in CPU. It holds program or data that will still be used in primary storage. Primary storage is faster than secondary storage. Secondary storage is not faster as compared to primary storage. Primary storage holds less data. Secondary storage holds large volume of data or fast. Then we move to input devices. Input devices are the devices that feed data and instruction to the computer. Contain devices which helps user to enter data into the computer, equipped to translate the human understandable language into a form understood by the computer. Most input devices are peripheral devices. Peripheral device is an auxiliary device that connects to and work with the computer. Example, mouse and keyboard. They are mainly used to put data into and get information from the computer. Examples are as displayed here: the mouse, the joystick, the keyboard, and sometimes sensors. Digitizer, scanner, magnetic ink card register, trackball, microphone, barcode reader. These are all input setups or input systems. Then output devices. Output device accepts output from the data processing device, converts it into form suitable for use by the computer's human operators. Examples are printers, speakers, VDU, as is visual display units, graphical user interfaces, and so on. As displayed here, we can see a visual display unit. We can also see a printer. We can see speakers as shown here. The motherboard is a single circuit board that connects all parts of the computer together. Responsible for connecting CPU, memory, hard drives, optical drives, video cards, sound card, and other ports and expansion cards directly or via cables, can be considered as the backbone of the computer. So it contains ports to connect all the internal components, as we've seen here on the display. It provides USB ports which allow compatible devices to be connected in plug-in, plug-out fashion. Then popular manufacturers include Intel, ASUS, Abit, Boystar, MSI, etc. Software. What is a software? A software is the non-intangible part of a computer, as we explained earlier. It is the computerized instructions that operate the computer, execute particular functions or tasks, and manipulate the data that actually give a definition function to a computer. For software, the instructions to perform various functions, it must be programmed. Software provides instructions to the computer. Software can be categorized into two. We have system software and application software. System software includes operating system and all the utilities that enable the computer to function. All utilities that control the motherboard system, they comes under system software. Each general purpose computer must have an operating system in order to run other programs. And these are all operating systems which we put them in system software. Operating systems, a collection of software that allows a computer to function. Example, like we have Windows NT, Windows 8, Mac OS, different versions, Linux, different types, Ubuntu, and even the almighty DOS. Most operating systems include a graphical user interface that makes the software user friendly. Application software, they are softwares that include programs that users access to carry out their basic and daily routines and itineraries. They include applications for the following functions. We have word processing, typing of documents, letters. We have spreadsheets, calculating numbers and doing calculations, formulas, activities on the computer. We have database management, which helps us to track different people, different items, and we have presentation software, and we have communication software. These are all software designed purposely for specific functions and activities, and as such are termed as application software. Software can be either proprietary, also called closed, or open. Proprietary software is privately owned and controlled by a company or individual.